I usually post this recorded video on Blackboard if you wanna watch it one more time. Yeah, welcome to watch. Yeah. Anyway, so we actually talk about the incidence rate, right? Yeah, it estimates the risk of disease in a space-time population during a space-time period. So this is the formula for incidence. Number of new cases during a specified time period over number of persons at risk of developing the disease during the specified period. And time constants, I'm going to talk about that. Let's talk about the new case. What is the new case? New case meaning. Okay, in September, there is a 50 people actually developed the disease. And then in September, there are already 150% have a disease. Which one is the new case? 50 or 150? In September, 50 people developed the disease, and also there are already 100 people had a disease. What is the new case? 50 or 100?
50.
Yes, 50. New case is a newly developed disease, right? Yeah, that is the new case. The number of new case during a space-time period and number of persons at risk. So let me talk about the at risk. So we actually this one talked about that one last time, but I think that's not that one. So think about this cancer, this disease, cervix cancer. Do you know the cervix cancer, right? So there are total populations. All the populations actually can be at risk or not. Especially we divide the gender, males and females. Which population is at risk for this cancer? Female, right? Yeah, females. So we probably at risk, we might need to exclude the men, right? For this disease, right? Only include the women at risk. And then this disease only developed between 25 and 69 usually. So we exclude the woman age between 0 to 25 and more than 70. So only who at risk population is 25 and 69 women, right? So this one. And then one more important assumptions about who at risk. If someone already had this disease, that someone is a 25 and woman, we need to exclude this person from who at risk or still need to include who at risk? People who already had that disease, do we need to exclude or include for who at risk? Okay, let's take an example. 100 women between 25 and 69. So we're actually talking about the cervix cancer. So 100 is actually who at risk, right? But almost 100, 20 women already had this disease. One number is who at risk. 80, right? 80 or 100? Yes, 80. Okay, let me take an example one more time. 100 women, 25 and 69. So this cancer 100, but almost 100 there are 20 women already have a disease. Who at risk number 80 or 100? Who at risk? Who at risk? Think about the meaning of who at risk.
80,
80. Why not 100?
because you exclude the 20 that already had it.
Yes. If someone had already disease, we need to exclude from who at risk, right? You already have a disease, right? So that's why people actually who do not have this disease are at risk. Okay, please keep in mind this one. So there are many tricky things here, but yeah. And the space-time period, during space-time period, it will be 1 year or 1 month or 2 year things, like kind of 1 month. Person have been followed for the time period. And then the K is actually constant to express the incident whole number to open 1,000 people or 10,000 people. So incidence rate does not use percentages, okay? We actually, instead of that, using these constants actually make easier to understand. So usually in the questions, this constant will be given 10,000 or 100,000 or something like that. So you just multiply this constant given the constant, okay? So let's take these example questions, okay? Read the questions and then let's get the incidence rate of lung cancer in the United States in 2004 per 10,000 people. So go back to this. This is formula. So please write down the formula in your paper right now. Okay. Yeah. Write down this formula and then working on these questions using that formula. Okay. Write down this formula and then working on these questions. Okay. Number of new case in a space-time period. So space-time period here, 2004, okay, not a 2005. So you might need to get the proper appropriate informations. Over total number of people who are risk. Okay, let's work on this one together. So this question asks about the incidence rate of lung cancer in the United States in 2004 per 10,000 people. So this one per 10,000 people is a constant, okay? Yeah. So you guys actually times 10,000. Okay. Look at your paper, and then the formula is actually number of new case in a space-time period, right? So 2004, what is the new case? How many new case in 2004 for lung cancer? This one? How about this one? Yes. The 2004 number of new case is 173,770, right? So we got this number here. Okay. Then balance. We need to figure out the number of who at least, right? What is the number of who at least? The total population of the United States in 2004 is right? That is the who at least? No. What we need to do more?
You need to subtract people who survived. 2003.
Which number?
453.
Very good. Why?
Because they already have one case.
Yes. This number of people in 2004, they already had a disease, right? So we need to subtract this number from the total population to get who at least, right? Yes, very good. And then times here's the constant, right? 10,000, right? Good. And then if we recalculate this one, and then we got 5.99 per 10,000 people, right? Yeah. Right? Yeah. So you don't need to worry about the roundup here. Okay, so I will give you a specific number later, but you don't need to worry about the roundup. But if you got this, if you using this formula and then you got around this number, you should be okay. Okay? Yes. That is the incidence rate. So don't forget this. We need to exclude people who already have a disease from number of who and list. Okay? Yeah, very good. Then let's move on to prevalence. So prevalence is the proportion of population who have a specific disease in a given period. This is the difference. So prevalence difference from incidence in that prevalence includes all case, both new and pre-existing case in the population at the specified time period, whereas incidence is limited to new case only. Here, meaning who have a specific disease, who have a disease. This means we include a new patient, and also we include pre-existing patients, right? And then here, incidence, we only include the new case, right? New case means that developed the disease at that time, but at that time, probably some people who already had a disease, right? Yeah. So we include both new case and pre-existing case. Okay, take an example over here. in September, 50 people developed the disease. And then there was already 100 people had a disease. What is the prevalence number? 150, right? Yeah. 50 new and 100 is a pre-existing. We add this one together. So prevalence is 150. Does it make sense? Okay, very good. So please write down this formula for prevalence. So number of cases of disease present in the population at a space-time period. So this is present in the time is both new case and pre-existing case, right? Yeah. And over prevalence, we're gonna use the total population. Okay. Prevalence, we use the total population, not OLEs. Okay. The prevalence use total population. So you don't need to worry about the number of people who already had a disease or not. So just use the total population. Okay. And then we still use constant. Okay. So let's do simple practice. Okay. So this means here, this arrow means left side. You guys actually left side here. This means the onset of the disease. Okay. And then actually this disease actually continues and until this point. And then this arrow means actually cure of disease or death from that disease. Either one. Okay. So the result of the disease. Okay. So this one is the onset, new case, and then this one's actually cure or death, the outcome of the this disease. So incidence in 2008, how many cases? Incidence. In 2008, from January to December, how many cases? Go back to this. This one means onset of disease, so new case, okay? And then this one is the outcome of the disease. So incidence in 2008, how many cases? How many new case?
Are you asking for which line?
Please. Between 2008. Who said two? Yes, two. Why two? Who's the two? Which one is two? Second and third, right? Yeah. It indicates the new case, right? So in 2008, only there are two cases, right? New case, right? Yeah. How about prevalence? How many cases?
5.
5 or 3?
5.
You change mind?
Yeah, that's fine.
Okay, yeah, 5. Yeah. Good. 5, 1, 2, 3. This is the pre-existing case, right? And then we already know that 2 new case, so there are 5 prevalence case, right? Yeah, so you guys can distinguish the between the prevalence new pre-existing and new case like this. So we're gonna working on. Okay, class. So let's moving on to practice questions. So practice questions actually also posted in Blackboard. So go to Blackboard and then the chapter 5. And here prevalence and incidence in class. So you can download this. Working on these practice questions, okay? Yeah, so after I will give you 10 minutes
to 15 minutes to working on this practice question, and then we're gonna moving on to work together for these practice questions. Okay, yeah.
Once ABC, let's do together, and then I will give you more time to do the next one. Okay. So the first one, calculate prevalence on October 1st. Prevalence include pre-existing case and new case, right? Yeah. Here, October 1st. This time period, right? Yeah, this time period. October 1st. At this time, how many cases? 6, right? 1, 2, 3, 4, 5, 6, right? So 6 over total 20 and times 1000, and then you can get the prevalence for the October 1st, right? Yeah. The first one, 2, 3, 4, 5, 6, right? Yeah. So 6 over 20 and times 1000, and then you can get 300 per 1000. Yes, right? Yeah. And then B, calculate prevalence between October 1st and September 30, 1991. So we need to calculate the prevalence between this time period and to this, right? From this to here, right? That is the prevalence. So prevalence during this time period. This one pre-existing, right? Yeah. And this one also pre-existing. And this one new case, pre-existing case, pre-existing, new case, pre-existing, new case. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10 over 20. Yes. And times 1000. Prevalence always use the total population. Total population here, right? Yeah. 10 over 20 and times 1000. So 500 per thousands, right? Yeah. Good. The last one, you said last one is a little bit kind of hard. So incidence between this time period, incidence, right? So incidence we include only new case, right? So how many new case during this time period? 4, right? This one, and this one, right? This is the only new case. So we got 4 right now, and then we need to figure out the number of who at risk, right? Number of who at risk. 20 is the total population. So 20 is the number of who at risk or not? No. We had a 20, but before this time period, we already had a 6 pre-existing case, right? 1, 2, 3, 4, 5, 6. This is the pre-existing. So we actually talk about we need to exclude people who had already disease, right? So in this time period, these 6 people already had a disease, right? So we need to exclude from who at least. So how many who at least?
14.
14. Yes. 4 over 14 times 1000. So you might get 280 something, right? Yeah. So does it make sense? Okay, so please working on the last 2 in the back page, okay? Yeah. So let's together working on the together quickly. So calculate September incidence rate COVID-19 per 10,000 people. So we can easily figure out the September new case, right? What is the new case? September 5,678, right? Yeah, so we can put 5,680. And then we need to figure out number of who at least in September, right? So total 3,957,000, right? In Oklahoma, right? And then we need to subtract minus one number. 65 or 55?
65.
65, right? Why 65?
Those were the pre-existing.
Yeah, pre-existing case. So we actually more detailed. Almost 65. How many is the pre-existing case in September? Pre-existing means we already had a disease, right? Yeah. 65 already had a disease, almost 55 actually. Almost then 55 recovered, right? Yeah. So 65 is actually pre-existing case, right? Yes. So total population minus 65, 929, and times 1000, you can get 14.59 per 10,000 people, right? Yeah. Good. Next question. Prevalence rate, COVID-19, September, same things. We need to figure out the pre-existing case, older case in September. How many new case?
5,000.
And then pre-existing case, how many? 65.
And you would add
600.
Yes, so 65 minus 55 times plus 5, 6, 7, 8. Why? Why we subtract this?
because they recovered.
They already recovered. Yes, that's correct. There is no more pre-existing case in September, right? Yeah. So please. Yeah. So minus this and plus 5,006, 7, 8, and then over total populations, right? And times 10,000. So you might wonder why we used this number in previous incident, right? But here is the point. Assuming that once infected will not be infected again. So that's why we need to exclude this person, right? So more detail, only pre-existing case in September is 65 minus 55. Does it make sense? It's kind of a little bit confused. Does it make sense? Not 65. Probably have a 65, but we need to exclude the 55 because they already have the recovered, right? In August, they recovered. So September, this case, 65 is no more pre-existing, right? Yes. So you got this number, 40.95 per 10,000 people. Right? Yeah.